third example. Solve the system by substitution. 2y equals x plus 2 and 6x minus 12y equals 0. Alright, now in all of these, there's only one place where you have a variable with a coefficient of 1, and that's in the top equation. So let's go ahead and solve that one for x. So I would get to subtract 2 from both sides. And I'm going to rewrite it as x equals 2y minus 2. Alright. So I've solved for x. So I'm going to plug in 2y minus 2 for x in the other equation. So we go over to the other equation, and we plug in the 2y minus 2. And now we get an equation with just a single variable, y. So we have 12y minus 12 minus 12y equals 0. Now on the left, the 12y minus 12y is 0, so I ended up with negative 12 equals 0. That's a problem. That's never going to be true. So this is one of those occasions where if any time you solve and you get a false statement, this is an inconsistent system. Do you remember what that means graphically if you get an inconsistent system where there's no solutions? It means they must have been parallel lines. So if you would have solved the first equation for y and the second equation for y and put it in slope-intercept form, they'll end up having the same slopes but different y-intercepts. So what's the answer to an inconsistent system? The answer is there is no solution to this. No solution. There's no order pair that's going to be a solution to both of those. Alright, here's another example. 1/4 x minus 2y equals 1 and x minus 8y equals 4. Alright, now which equation is the easiest to solve for a single variable so that you don't have to multiply or divide by a coefficient? Hopefully you got the second equation, solving for x. So this equation, if I solve for x, add 8y to both sides, 8y plus 4. Okay, so I'm going to plug that in the x of the other equation. So just writing that one again, 1/4 x minus 2y equals 1. Keep in mind we're going to replace x with the 8y plus 4, right? So we've got 1/4 8y plus 4 minus 2y is 1. Now do the distributive property here. You can do it. You can do fractions. Remember, you're only distributing what's in the parentheses. The minus 2y was not in the parentheses, so don't do that by 1/4. Alright, here, cancel and cancel. I'm going to have 2y plus 1 minus 2y equals 1. Well, 2y minus 2y is 0, so I'm going to have just 1 equals 1. What happened this time? It's always true. Alright. If you get, if you're solving for a system, you get something like this where it's always true. You didn't solve for x, right? We were trying, or you didn't solve for y in this case, right? The y kind of fell out of the problem. Then these must have been the same line written in different forms. So if you would have solved for y, you would have gotten that they were exactly the same line, same slope, same y-intercept. This is called a dependent system. And so these two lines would coincide if you would have graphed them. So the answer to the problem is an infinite number of solutions. You could say infinitely many solutions. The most correct way to really express this is that every ordered pair on either line, because of course it's the same line, is a solution to the system. We'll make it a little bit easier. We'll just say it's an infinite number of solutions, or you could write infinitely many solutions. So these last two examples were the special cases where you either come up with a false statement, which means there are no solutions, or you come up with a true statement, which means it's a dependent system